Did you look up at the night sky this week and notice something extraordinary? Across more than 20 states, from Alaska down to Illinois, Ohio, and even as far south as Texas and Alabama, Americans were treated to a once-in-a-generation light show. The Northern Lights, or Aurora Borealis, dancing overhead in vivid shades of green, purple, red, and blue. But what exactly caused this rare celestial event? And why are scientists and policymakers paying such close attention to it right now? Let's take a journey from the heart of the solar system to the skies above America to unravel this story. It all started with the sun. Specifically, a massive and volatile sunspot called Aurora 427 that unleashed a series of powerful eruptions over several days. On November 11th, 2025, the most intense solar flare of the year, a NX 5.1 class event, burst forth from this sunspot. This eruption was so energetic that it was accompanied by a wave of coronal mass ejections, or CMEs. In other words, huge clouds of magnetically charged solar plasma hurled at millions of miles per hour directly at Earth. Within hours, these CMEs slammed into our planet's magnetic field, igniting a geomagnetic storm classified as G4, or severe, the second highest level on the official space weather scale. For context, storms of this scale are rare and typically occur only a few times per decade. They can cause power grid irregularities, disrupt satellite communications, interfere with GPS signals and radio transmissions, and even pose risks to astronauts and high-altitude flights. But the most visible effect, of course, was the aeronautical spectacle, the Northern Lights, which typically remain locked to the Arctic Circle, spilled far south into the continental US as Earth's magnetic field responded to the solar onslaught. Sky watchers and professional photographers captured the auroras from remote Alaska, villages to Midwestern farmlands, and as far south as New Mexico and the Texas Panhandle. This unexpected reach was thanks to the intensity and composition of this series of CMEs, whose charged particles excited gases in our upper atmosphere, producing brilliant, shifting curtains of color. Reports poured in from amateur astronomers, travelers, and even regular Americans who'd never seen the aurora in their lifetimes. These geomagnetic conditions boosted auroral visibility not just in the US, but also in parts of Europe and even Asia, making this a truly global sky event. This solar storm is not a freak occurrence, but part of a larger pattern. The sun is nearing the peak of its 11-year solar cycle, a period of heightened activity that brings more flares, sunspots, and stormy outbursts. Every time the sun's poles flip, its magnetic field becomes especially tangled, fueling dramatic bursts of energy like the one that caused this week's events. Scientists and space agencies closely monitor these solar cycles, not just for the beauty of auroras, but because extreme solar storms can have major economic and geopolitical consequences. The infamous Carrington event of 1859, the strongest solar storm on record, caused telegraph wires to spark and led to widespread disruptions, a scenario that, in today's world of global satellites, intercontinental communications, and vulnerable power grids, could have much more severe implications. For now, the world celebrates this connection to cosmic phenomena, while governments and scientists sharpen their vigilance. Emerging technologies like space weather prediction centers, real-time satellite monitoring, and international data sharing agreements are crucial to preparing for the next big solar storm. So, the next time you see news of shimmering lights over American cities, remember, you're witnessing not just beauty, but a striking reminder of our interconnected mysteries and vulnerabilities under the same cosmic sky. Like, subscribe, and share your own Aurora stories in the comments. And stay tuned for more global news told from a universal perspective.